solve, dou u by dou t will be equals to dou square u divided by dou x square, where x is greater than 0, t is greater than 0, subjected to the condition that is ux of 0 comma t will be equals to 0, u of x comma t is bounded. U of x comma 0 will be equals to x when x is greater than 0 and less than 1. U of x comma 0 will be equals to 0 when x is greater than 1. So given dou u by dou t will be equals to dou square u divided by dou x square, where x is greater than 0, t is greater than 0. We have to take it as equation 1. So this ux of 0 comma t will be equals to 0. This is the boundary condition. And u of x comma t is bounded. So initial condition, this we have mentioned here. So this is the initial condition. So u of x comma 0 will be equals to x when x is greater than 0 less than 1 and 0 when x is greater than 1. So here we use the Fourier cosine transform formula on the both the side of the equation 1. This is the equation 1. We have to use the Fourier cosine formula. So that will be dou u by dou t, which will be equals to dou square u divided by dou x square. Why we have to use the cosine transform formula? Because ux of 0 comma t will be equals to 0. If we take u of 0 comma t, then will be equals to 0, then we have to take this sine transform formula, and otherwise we have to take ux of 0 comma t will be equals to 0 is the cosine transform formula. So after writing this, square root of 2 by pi 0 to infinity dou u by dou t cos sx dx, which will be equals to 0 to infinity dou square u divided by dou x square cos sx dx, and square root of 2 by pi. So square root of 2 by pi, why we have taken this d by dt? And because after taking this dou by dou t outside of the integral, and we can take d by dt. So 0 to infinity u into then the remaining u cos sx dx, and 0 to infinity dou square u divided by dou x square cos sx dx, and square root of 2 by pi. So here cos sx is nothing but first function, and dou square u divided by dou x square is second function. So here we have taken first and second function, so we have to solve this by the integration by the parts. So integration by the parts, and we know the formula of the integration of the parts, that is integration of u into v into dx will be equals to u into integration of v into dx minus integration of u dash and integration of v into dx into dx. So this is the integration of dou square u divided by dou x square cos sx dx, where cos sx dx is nothing but this is a first function and this is a second function. So cos sx 0 to infinity dou square u divided by dou x square into dx plus 0 to infinity sin sx into s 0 to infinity dou square u divided by dou x square into dx into dx. So here cos sx we have written the same, and again 0 to infinity, after integration of this dou square u divided by dou x square into dx, we get dou u by dou x, so which is we have to apply the limit from 0 to infinity, then plus 0 to infinity sin sx into s. So after applying 0 to infinity dou square u divided by dou x square into dx, we will get dou u into dou u divided by dou x into dx. So I have written the same thing here, you can see. Then after continuing this part, so like dou u by dou x is tends to 0 as x tends to infinity. So square root of 2 by pi 0 to infinity u into cos sx dx will be equals to u bar of c. So here we have if we have it is there like u into cos sx dx square root of 2 by pi. In this place we have to substitute this u bar of c, so that here I have taken du bar of c divided by dt is equals to square root of 2 by pi. Again the remaining RHS side we have written, that is cos sx into dou u by dou x 0 to infinity plus 0 to infinity sin sx s into dou u by dou x into dx. So we have to apply the limit. So when we apply the limit of infinity, then it will become 0. So this whole thing will get vanished, and then remaining part will be this. So 0 to, so we have written like we have taken square root of 2 by pi, and then yes, we have taken outside of the integral, then 0 to infinity sin sx dou u by dou x into dx. So again dou u bar of c divided by dt will be equals to square root of 2 by pi, or we have taken s outside, 0 to infinity sin sx dou u by dou x into dx. So we have to take the integration by the parts. So du bar c divided by dt will be equals to square root of 2 by pi s, and into 0 to infinity dou u by dou x sin sx into dx. So here sin sx is a first function and dou u by dou x is a second function. So du bar c divided by dt will be equals to square root of 2 by pi s into, so we will get sin sx u 0 to infinity minus 0 to infinity cos sx into s into dx after applying the integration by the parts. So we know that u tends to 0 as x tends to infinity. So this term will get cancelled and this term will get 0. So this term vanish and then the remaining is this term. Then we get minus 0 to infinity cos sx into s into dx. So square root of 2 by pi s. We have already know that square root of 2 by pi 0 to infinity u into cos sx dx will be equals to u bar of c. So we have to substitute in the place of u bar of c. We have to substitute square root of 2 by 9 square root of 2 by 9 u into cos sx, and here after applying the integration by the parts we will get square root of 2 by pi into s and 0 to infinity dou u by dou x sin sx into dx. So sin sx is first part and dou u by dou x is second part. Square root of 2 by pi into s. So sin sx into u 0 to infinity, applying the limit, minus 0 to infinity u cos sx into s dx. So where u tends to 0 and x tends to infinity, square root of 2 by pi into s. So why this term will vanish? Because sin sx into u, so after applying this limit 0 and infinity we will get old term as 0. So we will only write this term like 0 minus 0 to infinity u cos sx into s dx. So we have written s into s square, then minus will be minus, so in the place of square root of 2 by pi 0 to infinity u cos sx dx will be equals to u bar of c. So that we have written here. Then we have to send to this side. So du bar c divided by dt plus, after sending to this side will become plus s square u bar c will be equals to 0. So du bar c divided by dt plus s square u bar c will be equals to 0. Then we have to multiply dt on this side. So after multiplying dt and we will get du bar c plus s square u bar c into dt after multiplying this side, and this term will go to this, then when multiplied with the 0 we will get 0 here. Then we will continue. So divide this by u bar of c on both the side. After dividing, then du bar of c divided by u bar of c plus s square dt will be equals to 0. So we have to integrating on both the side. After integrate on both the side we get log u bar of c plus s square, that will be same, and here we will get t plus equals to log c. So after sending this to this side and this to this side we will get log u bar of c minus log c will be equals to minus s square t. So log u bar of c divided by c equals to minus s square t. After sending this log this side we will get e power minus s square t. So u bar of c will be equals to c into e power minus s square t. So that u bar of c in s of u bar of c s comma t will be equals to c into e power minus s square t, and which is the equation 2. Then we have to substitute t is equal to 0 at this equation 2. So we will get u bar of c will be s comma 0 will be equals to c, which is we have taken it as equation 3. By Fourier cosine transform, we know the formula, that is f of s will be equals to square root of 2 by pi 0 to infinity f of x cos sx into dx. Then we know the initial condition that we have taken, that u of x comma 0 will be equals to x when the limit x is greater than 0 and less than 1. For this we have to take instead of f of x, we have to take u of x s comma 0 will be equals to square root of 2 by pi 0 to infinity u of x comma 0 cos sx into dx. After taking this, then u bar of s comma 0 so equals to square root of 2 by pi, where I have taken in the initial condition, you have seen that x is greater than 0 less than 1. So 0 to 1, the limit varies from 0 to 1, x cos sx into dx. So here x into cos sx is there, so we have to again integration by the parts we have to apply. U bar of s comma 0 will be equals to square root of 2 by pi. Then after applying the integration by the parts, and we have to apply the limit from 0 to 1. So u bar of c s comma 0 will be equals to square root of 2 by pi and into sin s divided by s plus cos s divided by s square minus 1 divided by s square. So by 3 and 4, we have already know the 3. 3 is nothing but this equation is 3. So u bar of c s comma 0 will be equals to c. So in this place u bar of c s comma 0, so we have to substitute c equals to square root of 2 by pi sin s divided by s plus cos s divided by s square minus 1 by s square. So by the equation 2, we know u bar of c s comma t will be equals to c into e power minus s square into t. We already know the value of the c, so we have to substitute this value of c here, and then we will get u bar of c of s comma t value. Then we have to take a inverse Fourier cosine transform. So u of x comma t will be equals to square root of 2 by pi 0 to infinity u bar of c s comma t into cos x dx. So we know already u bar of c s comma t formula. So here we have written, so we have to substitute here, and this is the end of this problem. You can see, like after taking square root of 2 by pi into square root of 2 by pi 0 to infinity sin s divided by s plus cos s divided by s square minus 1 by s square cos sx into ds.